Alright, folks, we are continuing on with some C++ learning. Last time with these C++ modules, last time was references and pointers, going back over that and taking more in-depth notes, and then did a ring buffer solution for somewhat of a challenge problem, but more of just understanding classes and passing in structures to those classes and stuff like that. So time to get a little bit more formal with some enums and structs. That is this chapter. Okay. Introduction to program defined types. I think this will be a quicker review, because I've read through this in depth before, but I just don't have the notes for it on my iPad, so. Okay. I see this. C++. Categories of compound types. Enums, class types. Cool. All right. Now I know that. Name a program defined types by starting with a capital letter. Yeah, makes sense. Using program defined types throughout a multi-file program. To propagate type definitions in code files that need them, put them in headers. Yeah. Program defined type used only one code file should be defined in that code file, but if it's used elsewhere, used in a header. Okay. Okay, wait. What do they mean exempt from the one definition rule? However, using forward declarations does not work for types because the compiler typically needs to see the full definition of the given type. Okay. Must be able to propagate the full type definition to each code file that needs it. Given type is allowed to be defined in multiple code files. I see. User defined. Basic type. A class type or enumerated type? I see. Alright, unscoped enumerations. Color int. Sure. Enum is a compound data type whose values are restricted to a set of named symbolic constants. Okay. I mean, commas, not semicolons. Okay. Uh-huh. Makes sense. So it just kind of maps each to a given int value. This is all good and fine, but I want to define an unscoped enumerated type called monster type. Oh, okay. I've done this one before, but I've played these games before. But I'll redo it. Q1. PC is slow today. Holy. Monster type will have orc, goblin, troll, ogre, and skeleton. Okay. Pretty simple. Put the monster type enumeration inside a namespace and create a main to instantiate a troll. Okay. Int main. The program restricted pile? Okay. So let's call the class monster. It will be a monster type. Char1 is initiated to be a troll. I might need the namespace. I think I do need the namespace. Okay, and then we will do namespace monster. Cool. This is so slow. Holy. Okay. Let's just compare. Let's just compare. Namespace monster. Oh. Hang on. Am I able to do this with or without? Got it. Alright, we do not need the maybe unused here. Such bums. Okay. So that's the first one done. Unscoped enum integral conversions. Right. Values can be negative. It'll start incrementing from that one, and then we will do okay. They'll increment from where it left off. Value initializing and enumeration. Enumeration is 0 initialized. Will be given 0, even if there's no corresponding enumerator with that value. Oh, interesting. Empty enum assignment. Goes to 0. It's good to know. Oh, okay. Type defining. It's good to know. Int 8 underscore t. So it's colon. Typecast. Cool. The enumeration has explicitly defined underlying type. The range of the enumeration is identical to the range of the underlying type. Sure. Unscoped enumeration has an explicitly specified base, then the compiler will allow you to list initialize an unscoped enumeration using an integral value. Huh. True or false? Enumerators can be given an integer value. True. No explicit value. True. Previous enumerator plus 1. Given a floating point value. Believe false. Given a negative value. True. Given a non-unique value. Somehow true. Given the value of prior enumerator. No. Oh. Oh, and I guess I'll just default to, yeah, I'll convert to the n. Okay. Makes sense. Given a non-constant expression value. Ooh. Probably not. This is lame. Pet. Overloading the IO operators. You have to remember the name of the function we created to get. Sure. It's not crazy though. I'm gonna call such function adds clutter. You're not wrong. Overloading operator before we proceed. Okay. You're still using it, like, I just don't understand. Like, I get it, but... This expression is evaluated, the compiler will look at the overloaded operator. A function that can handle arguments. Yeah, it is optional that we get a match. Uh-huh. Alright. Scoped enums. This is scope enumeration. Color scope region. Compiler, the compiler doesn't know how to compare different types. I see. Oh. Scoped enums don't implicitly convert to int. Got it. Lack of implicit conversion to integers can sometimes be a pain point. Interesting. Imports all the enumerators from enum into the current scope. So using enum color. That's nice. Define an enum class named animal. Okay. Actually, hang on. Okay. An enum class. Whoa. Goat, cat, dog, duck. And then let's do a max animals. Cool. Write a function named getAnimalName that takes an animal parameter and uses a switch statement to return the name. Okay, so I need to include string view. Right? Is that the... Oh wait. I guess it doesn't really matter, but... Let's do std string view. And we're gonna do get animal name. Takes an animal. Animal. Switch. Animal. Case. What's the syntax? Ah. I got it. case, animal of pig, return bruh. Okay. Cool. Alright. So, chicken, chicks, goat, cat, and then we have a duck. What's our default? Yeah, makes sense. Cool. Okay. So that looks good. Then let's just take this whole thing and let's just want to return an int. Get number of legs. Print number of legs. Oh, print. Whoa. Print number of legs. Can I'm sorry, I'm gonna copy it. No. No, let's code. No, we should code. A blank has legs. Okay. Now, let me think about this. We have a group that's going to return 4 and a group that's going to return 2. So how can we group them all together? Oh, we can put them on the same thing. Okay, so pig. Okay. Cat also has 4. Dog and these have 2. And then default will be 0. As equals 0. Whoa, what the? And then I am going to get the test cases from them. What is it? Shoot. Okay. Well, then we have to return a string. Which is fine, but... Print number of legs. So this is before, so we have to do this. Okay, now we should be fine. Print number of legs is not in the scope. Huh? How is it not? How is it not in scope? Why would you capitalize an O? That is annoying. Oh. Oh, you're not breaking. There we are. Whoa. Okay. Introduction to structs, members, and member selection. aggregate initialization. What is an aggregate? Can contain multiple data members. Whew, okay. Hmm. Then each member without an explicit initializer is initialized as follows. If the member has a default, sure. Member is copied and initialized with an empty initializer list. Okay. Okay. Got it. I feel like the overloading is so unnecessary. Constructs. When adding a new member to aggregates. Okay, sure. Initializing a struct with another struct of the same type. I see. I see. Actually, that would be good to know. This last one. Explicit initialization takes precedence over default. Yep. Passing and returning structs. It's by reference. Yeah, we just pass it in like normal. Okay. I think I have this demo already done, but I'm forgetting what it would be called. Oh, what's enum classes? That's funny. Okay, cool. Website.cpp. You're running a website and you were trying to calculate your advertising revenue. Create a program that allows you to enter 3 pieces of data. How many ads were watched? What percentage of users clicked on an ad? Average earnings per clicked ad. Okay. So we'll have struct called data. Why not? We will have an int of num ads watched. We'll have a... We can also do this as an int. Percentage clicked. And we'll do this as a double average earnings. struct. Then we make a main that does std cout write a program that allows you to enter 3 pieces of data. Enter ads watched. std let's make our data view data cat. Then we'll do std cin. Wait, do we? I think we go that way. View data dot num ads watched. And then let's just go to a new line, std \n. Okay, and then we can take all of these. Num and enter percentage clicked. Percentage clicked. Average earnings. Whoa, wait. The print function should also print how much you made for that day. Oh. View data dot nums ad watched. Cool. Num ads watched times view data dot percentage clicked. View data dot average earnings per ad. Cool. And then we'll just add a std cout total earnings. Yep, there should be. 10, 50. Oh, this is gonna be so off. 20. We should do this divided by 100. Whoops. 10, 50, 2.99. Oh, it's gonna default to... Ah. Dang it. STD. What is it? Static cast. Double. Oh, they make click through. Oh, they make that a double? I guess that makes that part easier. $10, $50, $3. 10, 50, 2.99. Cool. Create a struct to hold a fraction. Okay. Obviously I could do this fairly easily, but, I just kind of I want to speed things up. Okay. Get fraction. Why would we return by reference? We're creating it in the class. Or in the function. I don't think it makes sense to do it by reference. Yeah. Struct miscellany. Structs that are owner should have... Okay. Makes sense. Don't let your member dangle. Amen. Member selection with pointer and reference. This is helpful, actually. Since references to an object act just like the object themselves. Uh-huh. We have to use our arrow. Sure. We can do that. Are they gonna show the... Okay. Pointer. What would be the name of this? Member selection for pointers to structs. Yeah. instead of cool. Chaining the operator. If the member accessed is a pointer to a class type, uh-huh, I see. Pointer to C to Y. Well, makes sense. Pointer goes to paw, paw then it goes to claws. Mm-hmm. Class templates. Mm-hmm. We would just add a template here, and then we just replace these with T. Template classes. Template. Type name T. Struct. Here. Cool. Prior definition. I see. Pair. Ah, okay. CTAD. Alright, we're almost done. I just need to wrap this up. Since CTAD is a form of type deduction, we can use literal suffixes. Class, template, argument deduction. types and the objects initializers. Why wouldn't this compile? No viable construction. This because CTAD doesn't know how to deduce the template arguments for aggregate class template. Oh. Oh, because they're too different? Oh. Deduction guide. See, this is where we go back and take notes in more depth. Pair of T, U goes to pair T, comma U. Here, reduction guide for our pair. Pair objects initialized with arguments T and U should deduce. Pair objects initialized with arguments. Should deduce to pair. Cool. Use the, okay, makes sense. So we can default our, When initializing a member of a class using non-static member initialization, CTAD will not work from this context. Right. Alias templates. Okay. Let's just go to the summary quiz. I hate to do this, but I've done this before. I'd rather do some of the knowledge check, if that's alright. Alright. Specify whether objects of each given type should be passed by value, const address, or const reference. You can assume the function takes these types as parameters, does not modify them. Char. Const reference is a fundamental type structure passed by value. Whoops. Const reference. Copy the string whenever it's copied, passed by const reference. Unsigned long. Passed by value. Bool, passed by value. Enum type. Reference. Oh, it should be passed by value? Enumerated types hold integral values. Oh. Fair enough. Struct position. This should be passed by const address. Or, okay, or const reference. More members will be added. Hello player only contains a single int. More members will be added in the future. So we want const reference. Fair enough. Int when null is a valid argument. Value? Passed by address. String view reference. Okay, I don't know string view, so that's fair. Create a class template named Triad. It has 3. Okay. I want to go over a knowledge check over this quiz. With chat. So we'll do quiz me on these. Learn C++ topics. Ask me one question at a time. What is the main purpose of a user-defined type in C++? A, to store only primitive data types, to group related data and or behavior into a single unit, define constants, optimate memory usage. It is B. Correctly defines an unscoped enum. B and C. What is the value of x? X equals 1. Wait. I thought it was to green. Oh, it's 2. That's... Yikes. Converting an enum to and from a string. What is the typical way to convert an enum to a string? Define a switch statement matching each enum. Cool. Alright. So the most common way is indeed to use a switch statement. To overload for printing a struct, the function must... No. It is B. What is the main difference between enum and enum class? Enum class is scoped. And they don't convert to int. Given what is the value of p dot y? P dot y equals 4. Which the following is not allowed with aggregate initialization. Ooh. Well, okay. It's B or C, and I'm thinking it's C because they don't have the semicolon there, but they could just be messing up. Correct answer is D. Interesting. Does not compile for an aggregate struct without a... okay. What are the values of p.x and p.y? Oh, are they initialized to 0, or is the default overriding? My thinking is you're specifying in the point, so I'm gonna say it's B. Yep. Which of the following is the most efficient way to pass a struct to a function if you don't want to modify it? You passed by the reference. Is false? Structs cannot have private members. What? Oh. I didn't know you could have private and... Oh, interesting. Which expression correctly accesses y through the pointer? C. Alright. Which of the following correctly defines... Wait. Oh, okay. Which following correctly defines a simple class template? That's A. CTAD. Okay. Templatized class. Box T value. What type will B have without explicitly specifying box int? 42 will default to an int, but I believe you have to specify the int. Okay. I guess that's the whole point. Which of the following correctly defines a type alias template? Ooh. Okay. Typedef template. I think it's C. You start it with using. Ah. Okay, fair enough. Which following is true about user-defined types? Only classes can have member functions. Enum classes implicitly convert to integers. Not true. Structs cannot have private members. I guess not true. Only classes can have member functions. B. You can have member functions in a struct. Structs can have member functions? Hang on. Constructs have methods. Huh. Okay. Alright, well that is going to be it from me for this session. I'll probably be back later working on a routing scheme for one of my classes, but that's it for now. See ya.